What's going on, guys? It's Dale here from DemmSec, and those who have been here for a while may remember that I've already kind of covered this topic, and the topic is DNS tunneling. And the old video showed like the old tools and how all that kind of stuff works, and it was so slow, but it worked, and it was kind of what we had there. So I've been toying with the idea of going ahead and making a new video here, because Iodine here, which is the new tool I recommend you use for doing DNS tunneling, is incredibly more high performance, more secure, all the things that we want from newer software. And right here you can see that compared to other DNS tunnel implementations, it's higher performance because they use a different DNS type, and here you can see the bandwidth is asymmetrical, and you get about a megabit per second, which doesn't sound like very much, but compared to the like few kilobit per second which we had with DNS to TCP and those kinds of tools, it's incredible, and it's pretty much like it's a usable internet connection. So the reason why you'd go ahead and use a DNS tunnel is mainly to bypass any kind of filters that may be going on. So if you connect to an access point and there's a captive portal, but you're able to do outbound DNS requests, then you can go ahead and use a DNS tunnel to get internet connectivity. But DNS tunnels also have like a penetration test inside, because there are actual payloads. I'm not sure if there's any in Metasploit, but there may well be, which actually use DNS packets as a means of communication. And it's a really stealthy approach, because there's a lot of tools, a lot of IPSs and stuff like that, IDSs even, which will detect HTTP traffic, and it may be able to point out, okay, this is it's on port 80, but this is OpenVPN traffic, or for example, the Meterpreter payloads, pretty much all the staged payloads are detected by antivirus based on network traffic. And so I guess if I open command prompt, when you're on maybe a captive portal or a lockdown network, the thing you're actually looking for, so I'm just going to ping Google, and you can see that I can get out to Google because I don't have any kind of limits in place. But even if I couldn't get a ping out to Google, if I can ping Google and get its IP address, that means that they're allowing outbound requests. So right here, where it's got the IP address of Google in my case, or whichever node of Google I'm hitting, if you can get that IP address, then you can do outbound DNS requests, and this type of approach will work. So setting it up, you're going to need some kind of server, and I'm using another DigitalOcean droplet, and down below there's a link where you can get a free $10 credit, so you can try this out for 2 months. This is only a $5 a month droplet, so go ahead if you want to try this. You've got 2 months of money there to run it outright, or you can just run it for 20 minutes and use it and bin it after that, and your $10 credit could last months. So what we need to go ahead and do is apt update, which you should always do. You should always update and upgrade when you launch a new droplet, because you're not completely aware of where the packages are on it. So I'm going to do an apt upgrade, and that's going to do a whole bunch of upgrades which are required. So now that that's finished upgrading, we need to go ahead and install Iodine on the system. So apt install Iodine. So now when we type Iodine and double tab, we get this Iodine D, which is the Iodine daemon, i.e. the server for Iodine, and that's what we're going to be running here. So I'm going to open the README just because you'll see how really simple it is to go ahead and do this, and quick start, that is all we really need for the quick start. So if we open back up our SSH session, if we do Iodine D and then -F and then a local IP address. So first let's do an IF config so we know what IP addresses are available here, and this is the server's IP address and the loopback address. So we don't have any other addresses in use other than this, so we can go ahead and do Iodine D and -F, and then we need an IP address. So I'm just going to put 10.0.0.1, just like in the example, and this needs to be an internal IP address, and this is it's kind of like a VPN over DNS packets. So this is going to be the starting address for the communication over this virtual network we're going to create over DNS. So that's the IP address, and then it needs the domain. So in my case, I've gone ahead and set up dnstunnel.iminyour.network, and later on in the video I'll show you how to configure all of this. So it's going to enter a password, and we need a password to actually, authenticate the users, so not just anyone can tunnel traffic over our DNS tunnel, which is, a pretty good thing. So I'm just going to put test1234. So test1234 is the password and is set up and listening. So the next thing you're going to need is a domain name. So obviously we're doing DNS requests here, so you'd kind of assume we need a domain name. And I'm using my inyour.network domain here. And I've gone ahead and created 2 records, and this is what you guys need to do. So the first one you need is a NS record, which is a name server record. And that needs to point to, it doesn't matter what this is named, but it needs to be pointed at a subdomain of your domain. So in my case, I'm doing tunnel host, which you can see down here, resolves to the IP address of the VPS. So that is an A record. So firstly, create the tunnel host, or you can go ahead and copy these and it'll work just fine. So in this case, I've done tunnel host, which is the A record pointing to the actual server. And then I've got a DNS tunnel NS record, which is pointing towards this IP address here. And that may not make much sense, but just go ahead and copy it and you'll see it works, and maybe then it'll make a bit more sense. With that all set up, we can now go ahead and use the DNS checker on the actual Iodine website, and that'll be linked down below. And we can do dnstunnel.iminyour.network and do check. And well done, it's set up, should be working. So the final thing is we need a client. So in my case, I've gone ahead and booted up a Kali VM, and I'm just going to have to log into this again. So I've got this Kali VM set up, and on this side we need to do Iodine. And the reason why I'm bringing up the README in this is simply so you guys can, actively go out there and learn how to use these tools without necessarily needing any help, because a lot of the time there's really good resources available, and here it's literally got a how-to of exactly how to set this up, but I just wanted to demonstrate it on video. So in this case we need to do Iodine. So instead of Iodine D, so we're not running a server, we're using the client, which is just Iodine. We need to do -F-R, and then we need to set the resolver IP. So this could either be the server's IP if you're able to get directly out to it, or it can just be the IP address of the local resolver and it'll forward it along. So if I'm going to do my router in this case, just to show you that it says here that it needs to be your server's IP address, but it doesn't necessarily. And then it's going to be dnstunnel.iminyour.network. And it's going to ask for the password, and in our case we did test1234. So we're getting bad handshake here, so I think I must have typed the password wrong on the server side, which is not really a massive issue. So just go ahead and rerun that and see if we can go ahead and run this. So we're getting bad IP, and the reason for that is it's expecting the server IP here, but it doesn't necessarily need it. So I'm going to add -C to the end of this. Oop. Sorry. On the server side, we need to change it to add a -C flag. And I've just changed the password to test this time. And then we should be able to do test. And with -C, it allows you to tunnel it over a regular DNS server, so you don't have to actively be able to get directly to the server. We can just forward the packets along the legitimate DNS server and hopefully get to our DNS server. So it's saying now that the connection is set up. So if we do an ifconfig, we'll see that we now have up here a DNS0 address, and it's got the next IP in the range. So if we ping 10.0.0.1, which you'll remember, if I move this over a little bit, is the IP we set up for the server, we can ping it, and that's going all over DNS packets. So the next question is, how do we go ahead and use this for web browsing? So the way in which I like to do it is, once we've got this set up, is create an SSH tunnel. So I'm going to do SSH root at 10.0.0.1, so it's going over the DNS tunnel, -D 8080, which is going to create a SOCKS proxy on port 8080 for us, and it's going to ask us whether we want to, we've only got pub key authentication, so just give me 2 seconds and I'll disable pub key only. So just because I've run into the issue of having to go ahead and add a public key to the SSH server, I just thought I'd show you how easy it is to go ahead and do that. So first we need to generate an SSH key, and we're going to do this on our client. So we're going to do SSH-keygen -t RSA. Oh, RSA keygen, sorry. Just going to say, where do you want to save it? We're going to go for empty passphrase. Obviously, don't do that. Actually add a passphrase, but in this case, we're fine without a passphrase. And we're going to do, we're going to cat the ID RSA pub. And this is our public key. So we're going to copy this. And then over here, we can do nano .ssh authorized keys. And then underneath here, we're going to paste our new authorized key. And then we should be able to go ahead and rerun this SSH command. And we've connected. So we should now have a SOCKS proxy running on port 8080. So let's open Firefox. With Firefox open now, we're going to go to the settings. Oh, it's got a lot of tabs that he wants to recover, but we're not going to do that right now. We're going to go to advanced settings. And then we're going to replace the HTTP proxy if you have one, or if you don't, hit manual proxy configuration. And SOCKS proxy, we're going to go for 127.0.0.1, which is localhost. And then we should be able to go to google.com over our DNS tunnel. And obviously it's not going to be as fast as your regular internet connection, but I think this is, quite usable. And just to show that we are going through the DNS tunnel, if I go to myip.is, we get the IP address of the server. And it really is that simple. So this is something which obviously could be abused, and I kind of implore you guys not to do that, but if you're going to do it, it's not my problem. Educational purposes only. I'm doing air quotes, but you can't see them, so that's fine. If you enjoyed this video, leave a like down below, subscribe if you haven't already, and I will see you next time. Goodbye.